Let's look now at sketching quadratics, and we're going to look at two different methods for this. The first method is going to be the method of factorization. So I look at the function that I've got here and I think to myself, well, that factorizes nicely into x plus 5 and x minus 3. So I would be able to tell that the roots of this equation are going to be at negative 5 and at positive 3. Now the roots tell me where the function will go through the x-axis. So one of those roots is negative 5 and the other root there is 3. I know from looking at the lead term that this is a positive x squared graph, so I should have a graph that looks something like this, so I can now sketch that through. And in fact, I know that this turning point is always going to be in the midpoint between the two roots. Now the midpoint here between 3 and minus 5 is negative 1. The other thing that I haven't drawn on at the moment is the y-axis. Now the y-axis actually should go through here on my graph, and the intercept here I can read straight from the original function. The intercept there is going to be negative 15. Now for completeness, I'll just mark on this minimum point and we could find the value there. We know that that minimum point occurred where x took the value negative 1, so substituting that into our function, I've got negative 1 squared plus 2 lots of negative 1 minus 15, which is going to give me 1 minus 2 minus 15, which is minus 16. So there, my minimum point is going to be at minus 1 and at negative 16. So that's the method of factorization. The second method that we would have would be to use completing the square. So I take my function and I look at completing the square, so that would become x minus 3 all squared minus 9 minus 7, which is x minus 3 all squared minus 16. Now, what do I want to do? Well, I'm thinking about how this graph of f of x relates to the general function x squared. Well, if I look at g of x minus 3, that would relate to x minus 3 all squared. Now the original function, g of x, I know would look like this, and I know that if I subtract 3 inside the function, I'm making a change in the x direction, and it's actually going to move the graph to the right by 3. So this point here is now 3. The next thing that I want to look at is subtracting 16. Now that happens outside the function, so that becomes g of x minus 3 minus 16, which would be x minus 3 all squared minus 16, which is the function that we actually want to plot. Well, if I'm subtracting outside the function, if it's outside the function, I'm affecting the y direction, so if I'm subtracting, it's just going to move the whole graph down by 16. So my graph is now going to go through something like this. How do I know that? Well, I knew from looking again at the constant term that this here was going to be negative 7. What's happened, I've translated my graph across by 3 because of this subtract 3 inside the function, and I've translated it down by 16 because of this negative 16 at the end. So always with completing the square version of graph sketching, we're comparing to the original function of x squared, and we're seeing where the function would move to, how it would move in the x direction and how it moves in the y direction. So here, my final sketch would look something like this, where we know that the coordinate of the minimum point is translated 3 across and 16 down, so that's going to be at 3, negative 16. I also know the intercept point because that was just the constant value on the end, which was negative 7. I might be interested here in trying to work out what the roots are. Well, in order to do that, I would then need to solve x minus 3 all squared minus 16 equals 0, or x minus 3 is equal to plus or minus the square root of 16, or x is equal to 3 plus or minus 4. So x comes up with two different values. One of those is negative 1, the other of those is 7. So I can then just pop those points on at negative 1 and 7. And yes, you can also see that in this case we could have done it by factorization, but I simply show the two different methods on these functions.